Assalamualaikum and salam sejahtera everyone. So today we are going to learn chapter 6, phase equilibrium. Okay, so at the end of this lesson, okay, so here you all should be able to define what does it mean by phase equilibrium, components, okay, and Raoult's law, and then identify phases and components in a system, differentiate between ideal solution and non-ideal solution. And for this one, sketch a phase diagram, boiling point composition diagram, and also eutectic diagram. This one we will cover it next week. Okay, now these are the subtopics that we will cover. Okay, for the first one is the definition and concept in terms of phases, components, and phase rule. Okay, next is one component system. We will learn the phase diagram of water and also carbon dioxide system. Okay, then we will learn the colligative properties. The colligative properties here involves calculation. Okay, calculation. Okay, now we look at phase equilibrium. Sorry. Okay, for phase equilibrium, the explanation is that a substance may exist in one or more state. One or more state here meaning that it can be in terms of solid, liquid, or gas. So, to simplify, we call it state. Sometimes we call it phase. Okay, so we for this chapter we only learn 3 types of state, which are solid, liquid, and gas. Okay, now the transformation from one phase to another is known as phase equilibrium. Okay, for example, solid to liquid. So the process here, we need to identify what is the process occurred, and the transition between these two, solid and liquid, we call it phase equilibrium. Okay, now what does this phase equilibrium tells us? Okay, from the phase equilibrium, we can determine the behavior of the element, the compound, and the solution. Okay, so we look at the definition for each of these items. Okay, phases, components, phase diagram, and also degree of freedom. Okay, now we look at phases first. Phases is that matter can exist in 3 stages. As I mentioned earlier, it can be in terms of solid, liquid, and gas. So we call it phase. Okay, I repeat, we call it phase. And this phase, the symbol is P, capital letter P. Okay, and this symbol P is used to represent the number of phases. How many phases are there in a beaker, in that solution, for example? Okay, so the phase here is defined as homogeneous part of system which is chemically or physically uniform throughout. Phase are separated from one another by physical boundaries known as phase boundary. Okay, so we look at phase. Okay, so it can be one phase system, two phase system. Okay, now for two phase system. Okay, for one phase system first. Okay, one phase system, one phase. Okay, for one phase system, let's say here in a beaker, it contains only water, H2O, in liquid form. So we look at the phase here. So the phase here is only one, which is liquid. So it is one phase system, 1P. Okay, now when we look at two phase system, okay, two phase system, a gas and a solid, Okay, let's say in this system, let's say here in this box, we have gas, okay, O2 gas in the form of gas, and also we have solid, Na solid. Okay, so here instead of looking at the element or compound, we just refer to the state or the phase. Here we have two phases, okay, two phases which are gas and solid. So here we have 2P. Okay, that is how we identify it. Okay, and then we look at D here, two immiscible liquids. Two immiscible liquids means that both are liquids, but it it is not homogeneous. Let's say in a beaker, we have a solution. It contains a mixture of oil and water. Oil should be on the upper part, so this is oil, and this is water, H2O, in liquid form. Both are in liquid, but these two are considered as two-phase system. Why? Because these two are not homogeneous. It form a layer. This layer here, we call it phase boundary. Okay, this is phase boundary to separate the two phases. Okay, now we have one phase system, two phase system, and three phase system. Three phase system, it can contain either a combination between solid, liquid, and gas. Okay, for example, if A solid react with B liquid and plus C gas, okay, we just refer to its state or the phases. Okay, if there are three different phases, then it is 3P. Okay, two immiscible liquids, you know that it is two liquid that are non-homogeneous. Okay, mixed together, and a combination with gas or maybe with a solid. Okay, so as long as we know that immiscible means two different liquid. Okay, two different phase. Okay, so as I mentioned here, for example, solution of sugar in water. Solution of sugar is solid originally, but when it dissolves in water, it forms a homogeneous solution. Once it forms homogeneous solution, we call it solution of sugar. So solution of sugar is liquid. Okay, solution of sugar is liquid because sugar already dissolved in water, and that is why we call it one phase system. Okay, mixture of gases. Look at gases only. So even though in that beaker it contains all two gas plus Cl2 gas plus nitrogen gas, look at, there are three different gases, but all are in the same phases, which is gas. So it is considered as one phase system. Okay, I repeat, even though there are more than one type of more than one type of compound exists, but all of them are in gaseous form, or maybe all of them are in solid form, it is considered as one phase system. Okay, for example, mixture of ice and water. Let's say here this is a beaker and this is water. So water is H2O in liquid, and then you have ice. Okay, we add ice inside the beaker, so inside the water. So this ice is also H2O, but this H2O is in the form of solid. Okay, so here we have two phase system because it contains solid and liquid. Okay, make sure you know the differences. Okay, what are they in that system? Okay, oil and water. Oil is liquid, water also liquid, but these two are not homogeneous, so it is two phase system. Okay, so make sure you know the difference. Okay, now component in general term. Okay, as I mentioned earlier, phase is the state. Now what is C? We call it component. Okay, component. Okay, for this component, it can be one component system, two component, three component, or more, depends on the system. But what does this component actually means? This component means chemical species. Okay, chemical species. Okay, for example, okay, this is beaker containing water and we have ice inside. Okay, ice. So this is H2O in liquid. Okay, this is ice, H2O in solid form. Okay, now the question, how many phases are there? So phase here, two phase, which are solid and liquid. how many component? Component is the chemical species inside the system. So the chemical species here is only water, H2O. So only one component, one C, which is H2O. Okay, so we need to identify the component here is any chemical species. It can be element, it can be compound, it can be molecules, it depends. Okay, for example, again, here we have a mixture of two immiscible liquids. We have oil and H2O. Okay, so the state here is two phases, both are liquids. Okay, liquid and liquid. But for the C, we have oil and H2O. Okay, two components. So it is also two components. Okay, we have oil and water. Okay, so we call it components. Okay, now we look at phase diagram.